So we have just got done doing all of these derivatives. And in that we were always using A's. And that's really just a notation that's used when you're going to be plugging in a number for it. But in this section, they kind of have you switch your point of view, and instead of using A's, they use X's. Okay? They use A when you're first learning it, so it's easier to see like f of A. You're plugging in something for your A, and it kind of helps solidify the, okay, I'm plugging in my number here. But then we got to those problems where we were just doing a generic f prime of A, and we weren't actually plugging in a number. In this section, we're doing the same thing, but instead of A, if we don't have a number to plug in, we're just going to keep it as an X. Okay, so really same idea, they just kind of switch notation a little bit in our book. We are also going to be talking more about what this means on a graph. So we have said this derivative, we use f prime for the derivative, that's the slope of the tangent line at a given point. And so we could use that to draw a graph of the derivative. So what I'm going to do is give you a graph here. And I want to just use this graph to draw my derivative. Now we're going to start out very generic here. We're just getting a rough sketch. So the derivative is the slope of the tangent line. So if I wanted to be exact, I would have to know the slope at every x value and plot those to get my y's. But let's look for easy values. Right here. What would the tangent line look like? Yeah, it would just be straight across. If you have a horizontal line, what's the slope? 0. So right there, the slope of the tangent line would be 0, so my derivative is going to be 0. Right here, the slope of the tangent line is 0. So again, my derivative will be 0. Do we have any more? Down here at the bottom. So what we see is anywhere your graph has a maximum or a minimum, the tangent line would be horizontal, and so its derivative would be 0. Okay. If I were to draw my tangent lines here, they would all be decreasing. So is that slope positive or negative? Negative. So my graph was decreasing, so here my derivative has to be negative this entire time. Right? If I'm not going to be real precise, I just know that it's negative. It's below the axis. Then my graph is increasing. So all my tangent lines would have what kind of slope? Positive. So it's got to be positive after that. We have to hit our next 0, so it's going to look something like this. What's true about this section? It's decreasing again, so it would be a negative slope. And then after this point, it is increasing, so it's always positive. Now, is my graph overly correct? No. All that's really correct on my graph is my x-intercepts and whether it's positive or negative. Okay, we are going to be using this idea to draw the sketches of our derivatives for a while. So bit by bit, we will add a little bit more until our sketches get better and better. But right now, all I'm looking for, do you have your x-intercepts? Do you have where your graph should be positive or negative? So the key points. Anywhere the tangent line is horizontal, your derivative is 0. When the graph is increasing, the derivative is positive. When the graph is decreasing, the derivative is negative. this is what we were doing yesterday. We have our function. Last night you were asked to find f prime of a. Today I'm saying find f prime of x. It's the same thing. We're doing the limit as h approaches 0, but instead of a's, we're just using x. So f of x plus h minus f of x all over h. So f of x plus h will be x plus h cubed minus x plus h minus f of x would just be x cubed minus x all over h. Okay, if you take x plus h and cube it, write it out 3 times. You get x to the third plus 3x squared h plus 3xh squared plus h cubed. Do I need to show you where I'm getting that? Do you guys know how? Just write it 3 times and start distributing. Minus the x plus h, so if I distribute that negative, it's minus x minus h. Minus, so if I distribute this, that's minus x cubed plus x. So what happens here? X cubed cancels and x cancels. Everything left is divisible by h, so if I go ahead and divide that, we get 3x squared plus 3xh plus h squared minus 1. So then if you plug in 0 for your h's, you get 3x squared minus 1. So that is my derivative. Part B, I asked you to compare the graphs of these things. Just kind of reinforce what we're talking about. So the first one was x to the third minus x. Second one is 3x squared minus 1. So my original, this is my blue one, you see it has a maximum here and minimum here. So my derivative should be 0 at those points. So then if you look at the red one, is that where it hits the x-axis? Until I got to that first point, my graph was increasing, so my derivative is positive. In between, it was decreasing, so my derivative turned out to be negative. Then the blue one was increasing, so my derivative was positive again. Okay, so it has those requirements that we talked about. Alright, I would like for you guys to see if you can work out this one for me. So you multiply by radical x plus h plus radical x on top and bottom. So on the top, so if you FOIL, you multiply the first two, the radical cancels, so you get x plus h. The outside and inside drop, minus the square root of x and the square root of x is just x. So the x's cancel. Then what can you do with your h? Yeah, h divided by h is just 1. So if you plug in a 0 for your h, you get square root of x plus the square root of x, or 1 over 2 square root of x. Okay, that's our derivative. Domain. I haven't asked you this in a while. Kind of a flashback to the first unit.
Would you do 2 the square root of x equals 0?
We know that this can't equal 0.
Yeah.
You're right. So divide by 2, so the square root of x can't be 0. Square, so x can't be 0. We also know that if it's under a radical, what has to be true about it? So x has to be greater than or equal to 0 because it's under the radical. But it can't equal 0 because it's on the bottom. So our domain is just parenthesis 0 to infinity. Everything bigger than 0, not including the 0. So far, so good? So, if we had looked at the graph of this, the square root function looks like this. 1 over the square root of 2x looks like this. What's happening, does this one ever have a maximum or a minimum? No, so it never actually hits the x-axis. It's always increasing, so our derivative is always positive. Right here, you see that this is, the tangent lines would be steeper here. So those are going to infinity, the slopes are getting larger. As we go on, what's happening to our tangent lines? They're getting flat, so it's turning into a horizontal asymptote. So we will continue to look more at this, but it's just showing us how that kind of turns out in our derivative. So basically, if your derivative, if your function is flattening as time goes on, then your derivative is going to be approaching a horizontal asymptote when we graph it. All right, let's find some more. I want f prime of x. So the limit h approaches 0, f of x plus h. So if I plug in an x plus h for this, minus the f of x all over h. So you could write that as 1 minus x minus h over 2 plus x plus h. Dividing by h, if you flip and multiply, that's like multiplying by 1 over h. What do I need to do with this? So I take this one times 2 plus x on top and bottom. And this one times 1 minus x minus h. So if we start distributing, we get 2 plus x minus 2x minus x squared minus 2h minus xh. Next one you get 1 minus x minus h minus x plus x squared minus xh. 2 right here? 2 minus x minus h? You guys weren't gonna correct me? Oh. Oh, what was I doing? Oh, I multiplied by the top. My goodness. Scratch that. Let's try again. So if I distribute, I get 2 plus x plus h minus 2x minus x squared minus xh. I'm sorry, guys. So then what do we do? Yeah. We distribute the negative. Positive 2, negative 2 cancel, positive x and negative x cancel. 2x and negative 2x, negative x squared, positive x squared, and x h's. So all we are left with, negative 2h minus h, so negative 3h over the denominator. So then you can cancel the h. So if you plug in a 0, you get 2 plus x plus 0 times 2 plus x, or negative 3 over 2 plus x squared. Alright, so really this is just the same thing that we were doing. Okay, I'm just using x instead of a. Questions there? Alright, we're going to talk about just a couple more things and then I'm going to stop for today. So the last bit I want to talk about is just some of the other notations that we might see that mean the same thing. Most of the time we've been seeing all of these have been f of x, but we know f of x is the same thing as y. So I could ask you to find y prime. Another notation that we see a lot is dy dx. That's a very common one that comes up. It just means the derivative of y in terms of x, so it's the same thing. It can be written all of these different ways, but really the first 3 are the ways you're going to see me write it. Okay, and any of those notations just mean find the derivative, which is what we have been doing. When we're using the dy dx notation, sometimes you'll see like a dy dx, a vertical bar, and then x equals a number. And so that means when you get to the end, you're going to plug that number in for your x. So it's just like saying, find f prime of 1. I might say find dy dx, then vertical line x equals 1. So it's just telling you you're going to plug a number in for your x at the end. So your answer will be a number, not a formula. Yeah, and then tomorrow we're going to pick up talking about when a function is differentiable, which is basically just saying where does the derivative exist. So we'll pick up with that piece tomorrow. If you guys look, I think I printed it on the back slide. Back of your notes slides, maybe? Okay. So first problem number 1. We are asked to use the graph to estimate the value of each derivative. So that is why I printed this for you. You might need like a ruler or a piece of paper so you can kind of draw a straight edge here. When I ask for f prime of negative 3. Okay, negative 3 is right here on my graph. And we are asked to estimate the derivative right there. So it's not going to be perfect. We are all just doing our best here. If we were to draw a tangent line there, it would have to be, well, I missed it, didn't I? A decreasing line, so something like this. If you were trying to estimate the slope of that line, you would have to have 2 points on that line, right? Are my points going to be very exact? No, we are just ballparking it, okay? So, let's say I tried to use this point and this point. If I were trying to do rise over run, okay, if I'm going up, about how far apart do you think those are? Maybe, is that like 2/10 below to 2/10 above, so maybe 0.4 apart? We're just estimating. Run, I go back 1, 2, so over -2. So I get a -0.2. I am going to be pretty generous with these, because obviously there is nothing precise about what I just did. You should have a negative, you should have something smaller than 1. It's clearly not a very steep line, but we can kind of get that approximation. The next one I asked for, f prime of -2. So when my x is -2, we're right here on the graph. What's that tangent line? What would the slope of that one be? 0. That one's just a horizontal line, so that one's 0. I'm pretty confident about it. F prime of -1. So -1 is right there on my graph. Okay, so if you try to draw your tangent line the best you could, I would take a couple points so we can kind of tell on that line. So if I started here, I would go up 1, so rise over run, and how far apart are those? Roughly 1 apart, you think? This is kind of like, it looks like they're about 1 apart, so 1/1 is about 1. Are you guys with me on this, or am I just doing your homework for you? Are you participating with me? Trying. So f prime of 0. So x equals 0 is right here. Would this one have a positive or negative slope? Let me ask that. Should be a positive, right? If I draw this tangent line, so it looks something like this. So if I estimate my rise over run, looks like we go up 2, run, let's see, that's like a -2/3. And what do we go to? About 1/3? You think it's about over 1? Maybe even a little more than that. It's like 1 point. You guys aren't helping me at all here. You can't give me anything here. I'm gonna stop doing this with you. Rise over run, we're estimating here. It's went further than 1, right? This would be at -1/3 approximately, so 1/3 would be 1. Went a little bit more than that, so maybe 1.3. Okay, divide this. 2 divided by 1.3, and we get about 1.5-ish. We are just estimating. I don't know if I can. So that's not exact, but it's a ballpark for that one. Okay, f prime of 1. is 1. You were right here. So if I wanted to estimate that, take a couple points, I would go up 1, over, thanks, to go up 1 over 1-ish. That one's about a slope of 1. At 2. So right there, get that one is 0 again. At 3. So ballpark to tangent line looks roughly like this. So if I were starting here, I would go up about 0.5. Go backwards, negative 1.5. So if you divide, you get about a negative 0.3. Roughly. Okay, then it wants us to use all of these to graph our derivative. Okay. So if I am graphing this derivative, I'm just plotting each of these points. So at negative 3, you get negative 0.2. At negative 2, we're at 0. At negative 1, we're at 1. 0, we're at 1.5. 1, 1. 2, 0. 3, negative 3. So then we could connect these points for our derivative. We can kind of see our graph is flattening out here, so our derivative is just kind of flattening out. There. So it looks something like that. Okay, so that was just our first practice at actually drawing the derivative. Not real exact because we estimated all those tangent lines, but it was ballpark. So that is why I printed the homework for you, was really just for that one problem. But I think you are ready to do several of these. Problem 3 is matching. Problem 5, you're just doing a rough sketch of your derivative, so looking at where it's 0, you're increasing, decreasing. Same with 7, 9. Yeah, you guys could already do. You could really work up through problem 29 so far. We've already done all of that stuff. This homework won't be due until Monday, but make sure you are doing a little bit each day so you're not panicking at the last minute trying to get it all done.